Marley and Mario, and we're going to take you on a very, very fun ride as well. And so let me start with setting a little bit of context for this conversation. First, I want to start you with a set of why are we building all these network security capabilities, and how do you put them together, and what's the right use case, in what ways should they be combined? And so I start always with what are you trying to protect, and in particular, how are you going to protect the application from malicious intent? How do you control the network and the application access? How do you do segmentation and isolation in the cloud? How do I enable DDoS, and do I need DDoS protection in this new world? And the most interesting one, I think, is how do I embrace this zero trust network security model? And this zero trust model was sort of coined in around 2010 by Forrester, and it's this framework where you really want to work with this idea that the network is not trustworthy, and that you really need to limit access to everything, and that is your best line of defense in this new world. And there's sort of several reasons for this model. The very first one is, the whole concept of the perimeter is gone, because as you have applications that spread on premises and in the cloud, your users are also more mobile. There's the use of a lot of different types of devices, and also the application pattern is quite different. Most applications now are composed of services, and some of those services come from either partner capabilities. You might have a data service from one. They're going to be more composed of different microservices. So really, you need that idea of the perimeter is really gone. And then the second one is, most of the data breaches that we've seen, and there's always one. In fact, I was just reading about a Home Depot one here that happened last week in their point of sale systems. Most of them are happening now from within the network. And so you really can't, usually they're looking at where's the point of entry that has the least security, and they use that then to move laterally. And so you really want a model that has this sort of zero trust model. And then the third thing is, as we digitally transform, developers are really trying to create and move fast, and they're embracing agile models, and they're really building more and more apps. And you want to empower them to be fast and create new things, but then how do you balance that with managing security risk? And misconfig can be as bad as a security vulnerability. And so while we want to embrace this, it's very, very important that you allow them to move fast, but then that your central IT also has ability to have some shared services that are protecting and managing the risk for the overall organization. The DDoS one is pretty interesting too. The most recently largest DDoS attack was 1.7 terabytes against the Ann Arbor network earlier this year. And we know they're coming now more often, and they're more and more sophisticated. And I don't think there's very many applications that can withstand that type of attack. And so as you think about, we're protecting the infrastructure, we're protecting the region, but your specific application, you have to think about, well, what does DDoS for your application really look like? And then the other thing that customers talk a lot about is, how do I manage data exfiltration? I don't want any internet access, but being practical, almost every back-end service needs some internet access, whether that is to pick up the latest code repository from GitHub. And so as we think about data exfiltration and internet policy controls, how do you put the right model in place? So earlier on Tuesday, we had an overview session on what's new in Azure networking. If you didn't get a chance to see that, I would really highly recommend that you look at it. I put the breakout session here. And this is kind of the framework for everything that we're doing in Azure networking. And what I want to talk about today is that as you look at how you connect up your networks, we offer both private connectivity options with ExpressRoute, and then newer internet-based connectivity models with SD-WAN, with our new virtual WAN offering. And then how do you construct your environment in the cloud with virtual networks? And so we're going to give you some context of how then you layer in protection with all those connectivity mechanisms. And then another thing that's very different about the cloud that we're seeing more and more is people are building global applications. And how do they then protect applications that are accelerated from the edge of the network? And what does security look like in these new delivery models? And especially as people are, there's a lot of lift and shift that's happening of applications. And those applications really weren't designed for the cloud or for maybe necessarily internet access. How do you layer network security services with those applications to ensure that they're protected in the cloud? And then most importantly, how do you then monitor, troubleshoot, debug all those issues to make sure that your entire environment is protected? So we're offering multiple services to help you with your overall defense in depth story, and we'll drill in here shortly. But one thing I want to point out is we have this concept of a virtual data center. We've had it now for many years, but it's going to have a major refresh here this month. And it's a set of documentations and guidelines that we publish on Azure.com about typical network topologies for customers. And so we're going to use that virtual data center concept here shortly, and Murli will walk you through that. We're going to tell Azure Firewall GA'd today. I think our key message for the Azure Firewall is it's an as-a-service offering. And it's quite different in that we're really looking at the as-a-service delivery model as kind of foundational going forward for security services. The second thing, we've got DDoS earlier this year, GA'd as well, and this was our exposure of our infrastructure services now tuned for your application and your ability to leverage that service for your specific application. We'll also take you through the web application firewall, and the most common question is, why 2 firewalls? And they really are for 2 different goals and 2 types of protections. But the web application firewall is really about protecting you against the most common web vulnerabilities, and it's primarily about how do you prevent data exfiltration and data filtration on the actual application that it's protecting. And then we have a number of network segmentation and isolation technologies with our network and application groups, as well as our how do you then bring PaaS services and how do you limit their access to the virtual network as well. So I'd like to invite Murli to come up and take us through the in-depth each of those services.
Thank you, Sinead. Thank you. So that was a great overview of the theme that we've been starting off throughout the session at Ignite. And hopefully it's very clear that we are building various security services as well as features to help you with connecting your on-premise workloads with your Azure seamlessly, as well as to protect your workloads against malicious threats of various sorts, even within the perimeter microsegmentation. And finally, the way you can deliver your content to your own customers with a lot of confidence. And last but not the least, you can also monitor all of it, which is very crucial. And that will be the theme that we will continue throughout the session today, highlighting as we walk through the features. And again, as Sinead has mentioned earlier, this is a concept, virtual data center. And again, this is just a logical architecture. This by no means is implying that you just have one of each. And I think that's pretty clear. But these parts that we would like to highlight are circled in red. So we want to focus particularly on the production features today, which is the firewall, which we just recently announced as generally being available. Along with it, we also have been having WAF for inbound HTTP web protection. And then we also use network security groups and application security groups for microsegmentation. And we will walk more in detail about them, but at a very high level, imagine that once something is inside your perimeter, how do you protect access even within there? There could be a lot of critical applications, and that's when NSGs and ASGs come in. But something coming into your own security perimeter, that's where firewall comes in. So those are some of the high-level views. And it also highlights some of how our services and the platforms are coming together, such as ExpressRoute, VPN gateway, as well as the VNet peering, application service endpoints, pass endpoints so that you can inject into your virtual network. And this helps you seamlessly connect and protect your resources. I want to talk more in detail about the Azure Firewall. And the greatest thing is, whoo, we are now GA. And we are super excited to be here. And we put in a lot of hard work. We've been listening a lot to our customers. And I'm so excited to say that we are one of the first amongst the cloud providers. And it's a great deal to be talking about it. And the most important things, the scenarios that we will highlight with Azure Firewall is the central governance of your monitoring and protection. Right? You may have multiple VNets, cross-subscriptions. How do you protect your resources across all of them? So that's where Firewall comes in. Similarly, we also provide complete VNet protection, including the VNet protection between just Azure VNets or expanded to your hybrid links using ExpressRoute or VPN gateway. And one of the things we commonly hear from our customers is maybe they are not constantly attacked. Maybe they do not have a lot of threats. But for your own compliance reasons, you want to make sure that you are able to see the logs and build your own CM integration systems so that you can have your own alerting, your own security actions to be able to integrate. And for that, we have integrated, this is very consistent with most of our services, is we integrated with Azure Diagnostics. So you can actually leverage the rich set of logs about what are the types of traffic that is flowing in for application, network, as well as NAT. And this is a very quick sneak preview of our features. And as you can see, since public preview, we have delivered several other new features. This highlights that we are constantly looking for your feedback, constantly iterating very fast. And we are trying to move fast to make sure we deliver the best features for you. So we started off with FQDN filtering, which is outbound filtering. If you want to go outside, if you want to say github.com allowed, nothing else, lock down your environment, bingo. And we've evolved the FQDN filtering to FQDN tags. We'll talk more about them. But this helps you group multiple FQDN rules together. And by default, one of the pain points we've heard from customers is, hey, I'm already running workloads on Azure, but we do not want to constantly, I don't know what are all the endpoints that I need to whitelist just for natively working. And so we have actually worked closely with our partners internally, first party, to whitelist a lot of these services. So you don't have to do anything. It just works out of the box. And we have also added NAT support so that you can publish your inbound services through Azure Firewall. Again, I want to emphasize, this is not your web application. This is your non-HTTPS workloads. And monitoring, we have added metrics. We will walk through all of them in a bit. And we will be integrating with Azure Security Center pretty soon. That will be one of the things. And I want to briefly talk about our successful public preview. We've been in public preview for about 3 months. There's a huge amount of excitement. And I really wish to continue that momentum because we've had partners and customers who are super excited and despite being in public preview, have already gone in production with us. That gives us a lot of confidence as well as helps you kind of relate with the customers and see if you're in the same boat. And in one of our earlier sessions on Tuesday, we had Jan Martin from ABN AMRO talk with Yusuf about how excited they were about Azure Firewall and how they have integrated Azure Firewall into their workloads to improve their CI/CD pipelines. And we are excited to have Simon here from Willis Towers. Simon, and he will walk us through how they are using Azure Firewall and his excitement about it.
G'day, everybody. I'm Simon Marley. I am the, as you can see, I'm the cloud platform architect at Willis Towers Watson. I'm part of the cloud enablement team in corporate IT. Willis Towers Watson is a global consultancy, insurance brokerage, and software solutions firm We operate in the financial market, so we're very heavily regulated in terms of providing security and compliance requirements for our clients. And as such, the Azure Firewall is going to be a great service to us. So from an architecture point of view, we operate a pretty standard hub and spoke model. The hub is managed by our corporate IT department, with our spoke VNets being our DevOps groups around the business that peer back. The connectivity back to on-prem is managed through ExpressRoute, as you can see. And at this point in time, we operate that model that was being talked about with the microsegmentation. We effectively treat all of our environment as a DMZ and provide that service for our NSG on every subnet. Currently, the internet connectivity, due to regulations, comes back through ExpressRoute to on-prem, where we have our security stack that manages that connectivity. Going forward, obviously, with the Azure Firewall, we're looking to complement the NSGs by providing that connectivity only within Azure and routing directly out. So that's going to be a great purpose for us, and obviously save the bandwidth on the ExpressRoute circuits. Obviously, the other features around the PaaS services with Azure Firewall, as we know for other PaaS services, we get the highly available, highly scalable support for this as well. That's was really what we need for this kind of a service to be available. We have the logging aspects to it as well. So one key compliance requirement we have for clients is to have a centralized login service. So having it as a PaaS service where we can use our NSG logs and consume our Azure Firewall logs into the same event hubs, which can then be consumed on premise through our corporate SIEM is a vital for us. So that's perfect for us. Going forward, we've also got other use cases for the virtual WAN that was also mentioned previously as well, to provide some more branch office connectivity to complement our ExpressRoute as well. But that's essentially our architecture.
Thank you, Simon. Cool. Again, thanks to Simon from Willis Towers for sharing their experience and use of Azure Firewall. And I'd like to now take a deeper look into the firewall features. So to begin with, we'll start with our inbound traffic filtering. And as we've been mentioning, the firewall, when we started off with outbound filtering explicitly because we already have web application firewall. But we also know that because of the asymmetric routes, it is not possible to publish everything. You will have to do a lot of control plane gimmicks. So instead of that, we have published inbound filtering, and we have seen a lot and more scenarios where we can integrate with SaaS WAF providers, such as Encapsula, where you can have WAF integrate with firewall and protect your resources from there. And we also, basically what we do is we are doing DNAT. The packet comes in on the published IP, and from there we forward it to the backend port. And we have we are enforcing some network traffic rules also on the inbound traffic. And there are a couple of known issues, so bear with us as we fix them very quickly. But there is a workaround on port 80 and port 22. FQDN tags, we briefly mentioned about this. And again, this is a roll-up of some of the most common workloads that we have seen, which is Windows updates, Windows diagnostics, application service endpoints, and maps, Microsoft map services, and one more thing. So we have about 5 FQDN tags that are already available at this time for you to use. And it is a roll-up of several FQDNs. Some of them are even like 2,000 FQDNs. And it will be, imagine what amount of effort it will be for you to go figure out all of them. So we've rolled it up into FQDN tags, and it's a very simple rule. I'll show you in a quick demo how you can just set up a rule that says, okay, I want to whitelist Windows updates. And some of you, if you do not want it, you just don't add it, right? And the next complex feature is our extension to the hybrid links. And it's the same. The data path is the same for Azure Firewall. But you can now leverage the power with some simple configuration where if you want to have a spoke connecting to the on-premise network, how would you like to protect it using Azure Firewall? And again, most of the policies and the control plane is going to be the same. You are going to configure the policies in a central management system, and the same rules will apply. You can specify the subnet ranges that you would like to protect, etc. But the configuration here is, this is a spoke VNet that you want to protect, that you want to filter the traffic going into the on-premise network. So the way you do is, you have to disable BGP on that particular, so you cannot discover, and on-premise cannot directly connect to this spoke VNet. And once you do that, you're also configuring a UDR on that particular spoke VNet to forward all of the traffic to Azure Firewall, right? So as a default gateway, anything that is not known goes into the Azure Firewall. And on the Azure Firewall, you're actually configuring a UDR to forward the traffic onto the on-premise network, okay? So you configure another UDR for this particular on-premise subnet because it's not discoverable by the spoke. So you forward it in, and then from there, the response comes back through because it is coming through the Azure Firewall. So just by configuring the UDR and some of these gateway settings, you're able to leverage the same power of Azure Firewall. So this is up on our documentation page, but this gives you the detailed steps on what is the recommended configuration. I know it can take some time for you to figure it out, so hopefully this will help you simplify. And we also understand that sometimes you may have created firewalls and you have attached it to the VNets as well as to the public IPs, but then maybe you have to take it off for various purposes, but you want to save the configuration. So we support deallocation and allocation. Again, it's a very simple through the PowerShell. As you can see, it's 3 lines of code to deallocate, and again, 3 lines of code to allocate. And this is very important because we've been hearing and we understand there are various security options and features. I want to make sure that you understand the synergies that we have with the rest of the protection stack at Azure. So we leverage application gateway, web application firewall for common known vulnerabilities that are documented in OWASP-based security. Mario will talk about them later in detail. And we have network security groups for segmentation, micro-segmentation. And finally, we have service endpoints where if you have workloads that need to be locked out to the internet, but you want access to storage, SQL, so on and so forth, you can use service endpoints for that. And today our integration with service endpoints is you can integrate them with Azure. So instead of enabling service endpoint directly on your workload subnet, you forward all the traffic to Azure Firewall, and then from there you can configure service endpoint. That way you can get centralized logging while getting the same capabilities. And before we jump into the demo, I want to quickly walk through our billing model. And we start off, this is, as Sinead has mentioned, this is a pay-as-you-go model. This is a SaaS service. And for that, we start off with a baseline of $1.25 an hour. And that is to make sure that you have some fixed price. And this should suit for most of you, about 90% of you. This should be very predictable. But we also need to make sure that because we auto-scale, we typically have almost unlimited bandwidth that we can scale to. This is a soft limit. So what you can do is, if your data throughput is pretty high, then we incur charges about 3 cents an hour per GB on data in, data out. And that's to account for the variable traffic. And again, although it feels like it's a combination of fixed and variable, I want to make sure that it is very clear. So most of the customers, you already know what your predictable workloads is. So for example, one of the customers was mentioning they have Windows backup or Windows updates running in at the same time around certain time frame. So during that time, you know how many times it's going to spike up, you know what your bill is going to be. So for other customers, I think just the typical fixed model is going to do. And also in terms of how many instances of the firewall that you may have to deploy. Again, it's very hard to say. It's very dependent on the architectures that you have. It ranges from a wide variety of the spectrum. But if you have a good example, as Simon had mentioned earlier, as well as Jan had mentioned, pre-prod, prod environments, you could have, if you want isolation, and you have the same kind of pipelines, you have firewall for each, right? And you do not, it's completely segmented. Similarly, there are certain customers who essentially say, hey, I want to categorize my workloads based on risk categories. I want this division to be red division. I don't want anyone to be accessing this. So you put a firewall to secure that perimeter. And you have other customer and other categories. So there are various combinations that you could achieve. It really depends on how you define your perimeters and where you want to put. So with that, I would like to shift gears into the demo. So I want to quickly walk you through the creation of the firewall and how simple it is going to be. So in this place, I just go into creating from the marketplace, search for firewall. And then here I just specify the resource group. I've pre-created the resource group so we don't have to waste time. And then we'll call this demo firewall. This is in the East US. And you can choose to use an existing network or create a new one. In this case, I'm going to create a new one. And I start off with some range. This is the firewall, because the portal already understands that we require an Azure Firewall subnet on the VNet. So if you choose to create an existing one, then make sure to have an Azure Firewall subnet created. And I can use an existing IP or create a new one. And that's pretty much it. So I had to specify the resource group, VNet, and my options for the public IP. And there you go. It takes about 4 to 5 minutes for it to create. So we're not going to wait for it to finish. And we'll now look through an existing firewall configuration where I want to walk you through some of the features. So here, you can see the overview section. Is the screen visible to everyone? Okay. So you have a private IP address. This is the IP address that you will configure your UDRs to. So you don't have to go anywhere, just go in the overview section. And if you want to understand for what IP it is going to egress out, because all of your traffic going through the firewall is going to egress out with the public IP, you can get that information here. So we'll take a quick look at what that is. And take a note, it's 4090.241.62. And we'll come back to the rules section. Again, it's a very simplified UI. We try to provide a very consistent view. So you start off with a NAT rule collection where I have an FTP and RDP published here. So you can expand and see what sort of rules I have. In this case, the RDP, I've published the public IP, forwarded to the internal IP of 10.2.0.4 on port 3389. And you can go and look at the network rule creations. It's a similar concept. And we will go ahead and try to look at application rule creation. So here, I can create a new rule. And the priority is very similar to what you are used to. The lower the number, higher the priority. So let's say I start off with 1,000. I already created that. And you can choose an action of allow or deny. And that applies to every single rule within this collection. And here I can just create a dummy rule. And this is where you can do some segmentation, where you want to say, hey, I want to allow access to github.com, but only from IPs originating from this, within this range. For simplicity, I'm just going to do this. You can specify the protocols. We also support non-standard HTTP, HTTPS. So if you have HTTP 8080, you can do that. And you can specify target FQDN, so something like github.com. and it supports wildcard at the beginning. And then you can also choose the FQDN tags. So that's how you can create. I'm going to discard the change because we already have an existing one. And let's take a look at how I configured this. So I've configured 3 rules within this rule collection. All of them are set to allow. By default, embracing the zero trust network model, we do not allow anything going outbound. So once traffic hits the firewall, it's going to drop everything until and unless you whitelist it. And the Windows update, all I have is, I've not specified any FQDNs. I've only specified the Windows update FQDN tag. And similarly, the Windows diagnostics is another one. I've just expanded them into multiple rules for simplicity, but you can choose multiple of them. You can even combine the FQDNs and FQDN tags. And I've allowed only Microsoft.com here. So, and we'll take a look at the metrics in a bit, but let me now try to log into the server that we just published. So that was the public IP, and there you go. So we are now logged into the server that is not exposed. It does not have any public endpoint. And let's take a quick look to make sure. So this is the FTP server that we are logged into. And if we can look at its overview, we do not see any public IP of its own. Do you see that? So through Azure Firewall, I'm able to RDP into a server that is behind, protected. And let's take a quick look at some of the whitelisting settings. So I have a Windows update open here, and I'm going to check for updates. If you do not have internet connectivity, this is going to say, sorry, could not connect. But here it has already found an update, and it is going ahead and downloading that. We'll also show some of the whitelisting here. So we said we are allowing only Microsoft.com. And there you go, it's coming up. And if you try to go and access, let's say, MSN.com, this is blocked. So this is a simple message we have, which just says it has been blocked because there is no default rule that is matched. So that's a quick overview of our outbound and inbound filtering. Hope that was quick. We just created a firewall very quickly. We configured with few simple clicks. And that's the simplicity we want to bring the firewall to you, a central pane of control with very simple management. And as we wait for this to finish up, so this has created. I want to drive home one point, which is most of us, when we say we are installing a firewall or deploying a firewall, we are scared that it may disrupt our network, right? But in this case, we are not doing anything intrusive unless and until you choose to route the traffic. So you don't, unless you create a route table and specify the UDRs to route to the traffic, you're not breaking any of your connectivity. And you can slowly start directing traffic from one subnet to the other, one subnet and the other through the firewall as you become more and more comfortable. So you can go ahead and start playing with it as of today. Now let's take a look at some of the logs. So as I said, so I'm on the same firewall, but on the metrics section here. So you can choose some of the metrics we have enabled. How many network rules have been hit, and how many application rules have been hit. So here's a quick counter of that. And we can also look at the logs, and I've pre-filled this to save time. But here you can choose the resource type to be Azure Firewalls and the category, and you can also filter by, I'm looking for DNAT rules. If I run that query, you can look at the messages. So again, the same experience of logging through Azure Diagnostics, where you can see the message. So we have a TCP request from this IP address, and that was DNATed to the 10204, okay? With that, I want to move back to the presentation. So hopefully that was a good overview of configuring the firewall and gives you enough for you to go ahead and try if you haven't already. How many of you have already tried firewall, Azure Firewall? It's good to see a few hands. Thank you. And now I want to focus on the ecosystem that we are building. Again, the same power of Azure Firewall exposed through the consistent REST APIs has enabled quite a few of our partners. Again, some of you might be here who are willing to integrate with Azure Firewall. You can go ahead now and start. There is nothing else that we need to do. I mean, of course, we'll continue to enrich, but we already have REST APIs that you can go ahead and integrate with. And I'm excited to talk about 3 of our partners, AlgoSec, who will very soon be integrating with us, and we'll have a preview coming up. Barracuda has been working very closely with us, and they already have a product that is ready for you in preview mode. They provide central management capabilities, and you might have seen more details about that later. There is a link at the bottom of the page for you to go ahead and check it out. They have a really cool video on how that works. And Tuffin is another one we have been working very closely with, who try to leverage the capabilities and power of Azure Firewall to protect container services. And again, I just want to add a little disclaimer. They are in preview right now. Azure Firewall does not yet support everything, all sorts of configurations with AKS yet. We are closely working with them to enable that soon. But I just want to highlight that in certain scenarios, this is going to be very powerful, and it's working. So I want to play a video here. I want to just correct the audio here. I need help getting the audio. Okay, we'll come back to it after the audio link is about. Sorry about that. And with that, I would like to hand off to Mario, who's going to walk us through DDoS protection as well as network security groups.
Thanks, Marty. Yeah, now let's talk about how this is actually working today on the industry. The first thing that Okay, let me move this a little bit. I don't think it's... Give me 1 second. Hello? Yeah, good. Awesome. Yeah, so the first one, before we jump in, we know, everybody knows about DDoS and how it's actually working and facing in the industry. The frequency, it's changing every time. It's continuously growing the impact into the customer's network. So we're seeing that this level of sophistication that DDoS attacks are getting every time, it's actually getting forward. So for any company or any organization to be protected for DDoS, it's very difficult to keep with the rate of changes that any of those level of attacks are actually impacting customers. Now, normally these DDoS attacks are not usually to just bring down the applications. They are usually trying to smoke or trying to enmascarate into infiltration on your networks. So essentially, someone that it's already within your network, they maybe want to just mask the attack and maybe stay within your network while you're attending the event that someone is actually compromising your network. And some of those are actually used as a weapon of attack, just to threat customers, and they have the power to actually, and resources to just create a massive scale attack on some of the customers. Now, having said that, on Microsoft, we provide DDoS protection to all of our customers. Every single public IP within Azure, it's already protected. No one has to do anything to actually get the benefits of this. We have already a built-in robust system to protect every one of the public IP traffic that is actually reaching the network. So if you're deploying an Azure, whether you're deploying any of the O365 products or any of your deployments in a VNet, all of your workloads are already protected by the basic SKU of the DDoS protection. This is by default. No one has to opt in for this option. One of the benefits is that all the learnings that we have in the industry, all the continuous learning that we have for DDoS attacks, we are already providing this to every one of our customers. So we basically don't want any one of our customers to be compromised by a DDoS attack in any way. Depending on your applications and the level of expertise that we have, is that we are continuously monitoring your workloads, and we are adapting depending on your workloads. So whether you're in different industries, like for example, if you're in the gaming industry, or maybe you have some voice traffic within your network, we are always adapting depending on your needs. So your workloads can be protected depending on the different thresholds that you have on your network. So one of the benefits that we have now for DDoS, and we thought, okay, this is a great protection for our customers, and we're giving this this basic protection for everyone. But maybe one of you might be interested on having a specialized and customized protection to your network, where you can have visibility onto what we're doing with this protection on your network. And this is called DDoS protection. It has a standard SKU. It's very simple to use within your VNet. It's only a matter of a sample clicks on the blades of the VNet. So once you create a VNet protection, DDoS protection for your network, what you get is the same benefits that we have on the basic protection, but it's customized to your workloads. What this means is that we are going to learn and adapt depending on your workloads. So if you have workloads that have different thresholds, we're going to basically adapt to your needs in a specific. The benefits for this, of course, is that not everyone has the same type of workloads. So not having the same type of workloads means that the basic protection that we're giving to everyone might not be the one that suits your needs. So you might want to think about how to protect your networks depending on your needs and depending on the traffic patterns that your own applications are having. So all of the benefits that we have listed here, we're going to go in detail into one of those and every one of those in the next slides. Essentially, we have a lot of tuning depending on your workloads. We're also learning from the traffic patterns that your applications has. All of your resources that you're deploying within the VNet, including the firewall, application gateway, WAF, all of your VPN gateways and VMs, of course, any of the path-injected services gets the same protection and the same level of analysis and monitoring within your network. So the first one of the benefits for having DDoS as standard SKU is that we are going to basically adapt depending on your needs. We have built in the platform a policy generation where every single minute we're basically monitoring the traffic and the packets, and we're noticing what's the trend of your traffic depending on your workloads. It might be that you have a seasonal traffic, and maybe depending on the season, if you're maybe on the sales industry, you're getting a lot of traffic that on a given date or maybe at different times. So that might be normal for your applications, but that might not be normal for anyone else's. So we're basically learning every minute, and then based on the learnings that we have on every single point on the network, we generate a prediction for the next 15 minutes, and then we can learn and adapt depending on your needs. So you don't have to actually go and interact with any of these policies. We basically kicked in the mitigation systems based on the patterns that we notice for your network. So this is the best of this type of configuration is that it doesn't need any specialized engineer to be there. We are basically doing this on behalf of our customers. As long as you have the DDoS protection, we're basically taking care of learning and adapting depending on the traffic that you're receiving. And so that's a great tool to have in your network. Now, what happens if when a DDoS attack is actually reaching into your network? Well, at the beginning, we're still noticing a lot of packets are actually getting delivered with certain amount of malicious profile. Like for example, someone is actually trying to send a lot of SIM packets and trying to get connections without really establishing the connection or the session, the TCP session within your network. So what we do in that is that we start analyzing all of the packets, and then whenever we have to kick in the mitigation system, we start to prevent by different methods. Some of those methods are not just dropping the packets or just dropping the connections. We basically learn from the techniques that the DDoS attackers are actually doing, and we adapt and we have measurements for every single one of those specialized attacks. Sometimes we just take the traffic and send it to another MUX, and we entertain a little bit of the attackers because, as you can think about from the attacker perspective, they have a lot of resources, but if you keep all of those resources just dropping the packets, then the logic on their scripting will be, then let me send another packet, and then if we continue to just drop the packets, then they will just keep going and going and going. But if we just adapt to those type of attacks, then maybe we can send the traffic to another MUX, and then maybe we can just keep the traffic in with certain amount of delays. So in that way, the attackers will actually have to consume a lot of more resources to successfully compromise the availability of your network. Now, all of this process is something that we basically give on the DDoS standard SKU. We basically give all of this information on what are the details on the attack and what's the measurement that we're actually taking or the action that we're taking to mitigate the problem. This is, of course, integrated within any of your logging systems like Splunk, OMS, or Azure Storage. The benefit of this is that if you have a hybrid strategy, maybe you have your on-premises and you also have Azure, or maybe you have a multi-cloud strategy where you have deployments in different places, you might want to take all of this data and ingest it into your own mitigation systems and maybe learn from that data and adjust in different places, not only within the cloud of Azure. So these are your, a little bit of details of how the report works. So basically, whenever we notice a DDoS attack is in progress, the first thing that we do is, of course, we give you a lot of analysis for the attack. The first one is a mitigation report. It's a full detail of what happened with the attack, with the top sources where the traffic is actually coming from. And we give also full details of the flows that we're actually receiving during the attack, where you can see the source IP addresses, the destination IP addresses that they were actually trying to hit, and the action that we took to actually mitigate the process. So all of this information will help you understand the patterns and how your applications are being executed and attacked by any DDoS type of threat. Another benefit that we give with the DDoS protection standard is the rapid response. This is basically just for peace of mind. Whenever you have an attack, you might want to reach out to someone to actually start some actions and drive some actions within and quickly respond to that attack if you're noticing that. So what happens is that DDoS is not something that evaluates on a packet per packet basis. So whenever we start noticing something, we just identify the patterns. But maybe at the beginning, within a few minutes, the packets will actually get passed, and your workloads will start receiving those packets. And then as soon as we notice that the pattern is not normal, then we start kicking the mitigation and then remediate the connections, and all the attacks will be actually forward to a different place. Now, the important piece here is that all the traffic that is valid for your application will continue to go through your application, so you don't have to really worry about your customers being suffering from your system being down. Now, what happens in this case, you have a DDoS response, rapid response at your help, which is a 15-minute response. You can just raise a support ticket within a specialized format that will give you the ability to get engaged with a specialized DDoS expert that can help you to mitigate and have some actions within your own protection plan. An extra benefit that it's also for DDoS standard protection is that all the traffic that was actually passing through within that short amount of time, it's considered internet traffic. So in Azure, we charge on a per metering model. So all of that traffic will not actually be charged to your account. So it's basically part of the protection plan, and you'll not get those excess charges into your account. And of course, this is also integrated with Azure Security Center, so we basically have a default recommendation for anyone that doesn't have DDoS protection. You'll get to see it as a recommendation because it's a great tool to have for customers that are not really looking for investing a lot of time into evolving and keep track of all of the levels of sophistication of attacks. All you have to do is just enable DDoS, and the same expertise that Microsoft has will be behind you, and you don't have to actually keep evolving your systems on that. So it's a very cool feature to have without any level of configuration on your network. So now let's start with a cool demo on DDoS. So.
Thank you, Mario. So last night I had a chance to validate if DDoS protection, how does it work? So Microsoft, along with the features that are documented that Mario has described, we also want to make sure and give you the confidence that you are indeed being protected. So we have partnered with a company called Breaking Cloud, who has provided us tools to simulate DDoS attacks against, of course, the public IPs that we own. Otherwise, we don't want to launch DDoS attacks against someone. So it's integrated with Azure. And okay. So I'm going to show you quickly that last night when I triggered a couple of attacks, there is a quick metric. So all I did is I went into the monitor section, and then I select the metrics, and I configured the endpoint that is of interest. So DDoS protection offers protection to various endpoints on your virtual network. Once you choose, there is basic protection, but also standard protection. And I chose the particular IP that I want, that is of interest, that I've attacked. And as you can see, there were a couple of attacks, one last night and one early in the morning. Then the system has effectively detected the DDoS attack. And what has it done to protect the resources? So if you see here, there is a big spike here, and there was an inbound 137.7 KB packets per second, TCP packets that I was flooding the system with. And of course, this is a very demo workload, so I don't expect that. So the DDoS system has learned that this is an attack, because this is not the normal throughput. If you leverage the basic protection, it may not understand that this is the level. So it has automatically stopped dropping all the packets, a majority of the packets. Okay? And again, this based on the tune, if I continue to play and if it is a real mixed load, this system will continue to adapt. Okay? So hopefully that was a quick peek of the power of DDoS protection and how you can validate it. Thank you.
This is cool. Now let's get a little bit into the VNet. Another option that just I'll go quickly through it. It's the web application firewall. I think we have talked a little bit, and we had a session on detail with this product. It is just for basic understanding. Whenever you have a session for DMZ, the WAF is one of those important components that you probably want to have, which is the protection for common vulnerabilities on web applications. This is a very basic product that you should always have whenever you're embracing your developers to rapidly and agile empower them with continuously building applications. For a network admin perspective, you might not want to have continuously monitoring into the process for developers, how they are actually developing applications, and if they're actually building enough testing in their APIs. If you don't want to be in that mode where you're actually just reviewing a lot of test plans, the best case is to have a WAF that actually gives you that level of protection without having to worry about developers bringing any vulnerability to your network. So the WAF will give you the basics for any type specialized web application vulnerabilities like cross-site scripting and of course SQL injection. So it will actually learn based on the patterns and the traffic that it's actually reaching, and it will automatically protect you. And basically your workloads behind will never actually will not be reached by any traffic being hit by any of those vulnerabilities. So you don't have to worry about actually enabling anything extra. Of course, this is integrated within Azure Security Center and also within Azure Monitoring. the same logins and metrics that you are familiar with, you'll have them as well, and you can actually learn and combine within the different set of products within Azure to combine a good view of how your applications are getting protected. This is, of course, for inbound traffic. We're using HTTP and HTTPS. This is just a slide with all of the benefits that we have announced within this Ignite, which is you have the ability to connect with AKS clusters with an ingress controller. You have the ability to protect web apps, which was already there. You have a lot of improvements with respect to performance. It's getting deployed within less than 5 minutes. It also has an improved performance on programming. Availability is also improved significantly. You have now cross ACs deployment, so you can be safely deploying into multiple availability zones, and your deployments will be fine because your gateways will actually be resilient between multiple ACs. The SSL offloads are actually have a significant improvement on performance. So this is just a list of improvements, and for more details, I think we can go and review a session that we had on Wednesday where we went deep into that product and with more advanced capabilities. Now, coming now within your network, now having a firewall, it's a great thing to have. But once you're getting into the network, it might be a good strategy to actually start with your segmentation within your network. So for all the VNet traffic, just because someone actually bypasses the firewall doesn't mean that they should have access to your most critical workloads. Like if you have databases or things like that, anyone that has any intrusion within your network should not be able to easily connect to any other place. Now, this is coming within the same best practices, which is the zero trust model. So within your network, you should treat it as a compromised network in the sense that everything that you're actually deploying there should only accept the traffic from the workloads that you know that should be identifiable. So for this, we have a couple of products that are in combination gives you the micro-segmentation and network security within your network. The first one, it's ASG. ASG's application security groups is just the ability to group the VMs freely. It's very tag-based approach. You just define monikers, and then you can group the VMs in whichever way you like. By grouping the VMs now, what you can do with NSGs is define your policy for traffic within your network, and you don't really have to maintain any IP-based ACLing. You don't have to worry about where those applications are actually landing to and how they are scaling, because they might be scaling in different ways, and they might not be very static. So if you don't really want to deal with IP-based firewalling, all you have to do is group the VMs and define the rules in whichever order you like. What this gives you is the ability to scale depending on your own developers. They can create their own application security groups, and all you have to do is give them the rules that you want to actually enforce for them. Definition of the policy doesn't really require any single VM, so the steps that we usually recommend is creating your policy, like your groups and then your rules, and all you have to do after that is just go and continuously create new workloads and just tag the VM with the appropriate workload. So at that moment, for example, in the picture that we have here, creating more application servers is just a matter of deploying the VM and describing that VM as an app VM. And one of the benefits that you get with this is it's, of course, a free configuration that you have for your VNet workloads. What you'll get, the benefits on the zero trust model is that anyone that is compromising any of your workloads will not have a full access to the rest of your network. So your network will be protected. At least it will be a little bit more difficult for anyone to actually breach into your most critical workloads, because they will have to continuously expand into the next layer, and it will be a little bit more difficult. By the time they can get access to your critical workloads, it might be that you already have some mitigation systems that have moved that VM into a compromised section, or maybe just remove the untrusted VM from the network. It's building with the same logging capabilities and troubleshooting. You can ingest the data into your own logging systems. You can send the traffic to a storage account and analyze the patterns within your network and see what's going on, and maybe detect any unusual patterns on your network based on the flow logs that we have on the feature. It's also integrated with Security Center. You have GIT access policy whenever you need a rule that it's only available for a short period of time. Maybe it's an access that it's only given based on a process that you have defined on your corporation. So you can use that git access policy to just give access for a given amount of time that is shortly within your network. Now, having said that, whenever you think about a high scale, the level of simplification that we give for VNet traffic, it's the ability to combine all the rules and maybe fewer NSGs. So having fewer NSGs gives you better visibility into your network, and then you can leverage more elaborated scenarios. Like, for example, if you have a quarantines VM scenario, I have just one rule at the top that has the highest priority, and it's a denied rule to an empty group that may be the quarantines VM. So for this scenario, that group might be empty at the beginning, but if I have maybe any threat analysis on the login, and I have noticed that one of the VMs for any reason it's compromised, then I can just tag that VM into that group and just put it into making that VM part of the group. You don't have to go around all the rules and figure what's the appropriate set of rules for that VM. All you have to do is tag the VM with that group, and that will enforce that no new connection will actually get established because you have a high rule that it's enforcing that type of policy. So complex scenarios like this one can be leveraged, and of course, getting the intelligence from different sources will help you to actually leverage this type of scenarios like the quarantine VMs. The next one is the combination of service endpoints. In this Ignite, we have the announcement of service endpoint policies. I'm going to talk about it a little bit in detail on what it is. It's basically another zero trust product that you can use, where you have the ability to define what are the storage accounts that you're trusting from your network, and then use in combination with service endpoints to only trust the storage accounts that you're accessing to. So the benefits for this is that all the traffic that is going to any other storage account will not be accepted, and it's also at an application layer in the sense that all this traffic will be actually accessed within your subnet, and no one else will actually be able to access any other storage account. The description of service endpoint policies is not based on FQDN. The reasons for that, it's a little bit, there's a lot of benefits of that, is that you're using a subscription type of mechanism to define the policy. So what that means is that you can just describe your subscription and then /start, and that will give you access to all the storage accounts within your subscription. Of course, you can add many subscriptions into the same policy. The benefit of this is that one storage account usually has like 5 different FQDNs. So it's really hard to manage the access to storage accounts by FQDN because they might grow into services, and it's really not the resource that you're creating for, and it's not deeply connected within your path story, which is using resources on ARM. Another reason for that is that maybe you don't want to continuously scale into storage accounts and keep adding that into your policy. So every time you create a new storage account, you have to remember to go back into your firewall and create another FQDN entry. So that might not be an ideal solution for your scenario. So that's why the policies are described based on resources. And what that gives you is the full confidence that you're only accessing the resources that you're trusting to without having to have a lot of maintenance problem. Now, I'll go a little bit more in details on how to configure and combine the products with respect to service endpoints. If we take, for a moment, the service endpoint policies out of the picture, what you can do is on the source subnet, you don't have to enable service endpoints on that subnet. What happens is that if you enable service endpoints, the traffic will be routed directly to the service. So in order to avoid that, and if you really want to inspect the packets and filter and enforce the policy on the Azure Firewall, all you have to do is not enable service endpoints, but enable a route, a UDR, a user-defined routes, to send the traffic over the firewall. Now, the firewall will be responsible for all the traffic that it's being processed by your FQDNs, and it will actually give access only to the resources that you're actually trusting. The rest of the resources will not be accepted by the firewall, so therefore your exfiltration concerns or any access to any past resource will also be covered. Now, this is the right configuration. Just don't enable service endpoints on the source subnet, enable it on the firewall, and then you'll be able to lock down access on the resource from the internet. So at the end, you'll get all the benefits from both the firewall filtering your resources and then the service endpoints giving you access and the power to lock down resources to your VNet only. So all traffic from internet, of course, to the resource will not be accepted. Now, coming now to the service endpoint policy, which is the one at the bottom, If you need a granular level of segmentation and access controls, what you can do, in this case, if we have a storage enabled, you can enable service endpoints on the same subnet and then apply the policy right there. All that traffic does not need to be on the firewall. And so what this will do is that it will give you the same benefits from the policy definition. You will not have to worry about the specific FQDNs, and you only access the storage accounts that you trust to. The rest will be dropped. So this type of configuration will guarantee that only the traffic that is going to the internet will pass through the firewall. And then in combination, you'll get the zero trust model for PaaS services integrated within your VNet, and of course the firewall for anything that it's internet traffic. Now, this is just an example on how we can combine the products. At the end of the day, the VNet strategy is to put all the services in a VNet. So as long as you have the right amount of tools to secure your PaaS resources into your VNet, you'll be in a good situation with respect to zero trust model.
We're almost there. This is the last slide. So I just want to bring it all together for you and just briefly talk about the 5 capabilities that we have. And the first one is like for DDoS, think of it as if you've got public IPs, you'll probably want to have the DDoS service so that you can protect yourself against DDoS attacks. And then it's another key benefit of the DDoS service is the visibility into the source of the attack. And then the third thing is actually to protect your bill. And one of the things that the DDoS offering comes with is if you do sustain an attack, you won't be paying for all the consumption that a DDoS attack caused. And so that's sort of one of the, if you look at the DDoS service. And then our web application firewall that we told you about, that's all about how do I protect my web applications against the most common vulnerabilities. And it's completely integrated into your application, the app gateway. So it's part of your layer 7 load balancing. It's super easy to add it and augment your and protect the application. And sort of giving you that centralized inbound web control. And then the firewall is really about the traffic flows. How do I control all the traffic flows? How do I log all the traffic flows? How do I have that central control? And so sort of think of it as a central control for inbound and outbound traffic. And then the nice thing is that it works both at the layer 3, at the network level, and at the layer 7. So you're able to use the FQDN rules as well. And we'll continue to advance our insight and knowledge into the Azure platform so you can create really, really simple rules. And then how do you augment that with the network security groups and application security groups? And so there you want to think about, it's really a distributed system. Think of it, it's applying it at the VM or at the subnet or at the container pod. And so it's sort of how do you get that control? And you really want to give your developers the ability to create controls both in their resources and then in the shared central resources. So we really like this sort of hub and spoke model where the infrastructure IT team can set some rules and then the DevOps teams can also set rules because they understand the application really, really well. And then further to that, then how do you even further control access between your VNet and the Azure resources? And how do you lock down the Azure resources with service endpoints? One thing we didn't cover today is while we're focused here on all of the services that Microsoft provides, we're a very partner-centric company, and we have some very good partners who have all of their offerings available in the marketplace. And you can replace each layer here. There's a third party that might be a better option for you because they have more extensive support or they've got richer capabilities. So I really want to focus that, and we have a huge focus now on how do we have better integration. And many of those partners are also transitioning to the as-a-service model. And so we want to look at sort of how do we combine our services with their solutions. And if you had seen the video, the Barracuda video, that was one example of they're doing central management on top of the native controls. I wish we could have shown you the Toughen one. It was a very nice one where they showed conceptually how they were learning the container communication pattern and then applying, creating the rules then based on the communication patterns they observed. And if you stay around later, we can maybe play that. But that was another very interesting example of where partners are now innovating on the Azure platform and extending it to additional use cases. So with that in mind, we didn't really have time for questions, but if we are going to be here for the next half hour, if you want to come up and ask us, we'd love to work with you as we all bring our workloads to the cloud. So thank you, everybody.